This is Matthew Craig, and this is a continuation from the first part of the video, day 14 examples. I wanted to break it up into two smaller videos instead of having one larger video. This is question 2 on the examples. Question 2 asks, calcium metal and nitrogen gas will react to produce calcium nitride. Calculate the mass of the calcium nitride that can be produced from the reaction of 75 grams of calcium with 25 grams of nitrogen. Part A. First, determine the limiting reactant, as we did in question number 1. First thing we need to do, obviously, is to write out the balanced equation. Okay, so once we have the balanced equation, then we can write other things that we know about the question, like we have 75 grams of calcium, we have 25 grams of nitrogen, and the question's ultimately asking how much calcium nitride is going to be formed. Alright, well, in some questions, like on your homework, I may not ask this question from part A, where it says determine the limiting reactant. That's okay, because by the time you get ready to take the AP exam, you should be conditioned or realize that if you have two starting amounts, or an amount for each of the reactants, you need to find out which is the limiting reactant. Don't just automatically pick one to find out how much of the product is formed. So what we need to do is, again, pick one and determine who the limiting reactant is. So what I did was I actually chose the calcium, not because it's listed first, but it just doesn't matter which one you pick, to be honest. But I picked the calcium. So again, this is considered our limiting reactant step. We always want to do the limiting reactant step before we answer any question. If we have two reactant amounts, we must do the limiting reactant step. So again, we'll take the 75 grams of the calcium, convert it to moles. Once we have our number of moles, now we're going to do a mole ratio. Again, just like in question number 1, we want to compare moles of calcium to moles of nitrogen. So I'm going to have my 3 moles of calcium on the bottom, 1 mole of nitrogen on the top. Now again, I could stop right here and have the number of moles of nitrogen, but that really doesn't help me because the amount of nitrogen that was given here is in grams. So I need to convert or go one more step and convert the moles of nitrogen into grams of nitrogen. Once I've done that and I do my calculation, I find out that I'll get 17.48 grams of nitrogen. And what that means is that if I use all 75 grams of my calcium, I will need at least 17.48 grams of nitrogen. If I go back up to my given information here, I have 25 grams of nitrogen. So again, if I use all 75 grams of nitrogen, I'm going to need at least 17.5 grams. I have more. So who's my limiting reactant? Hopefully you said calcium, because when this reaction runs to completion, all 75 grams of the calcium will be consumed. And then we'll only use 17.48 grams of the nitrogen, leaving some behind. So when we do our calculation, we need to be aware of who is going to 0. That's what the limiting reactant will. It'll be totally consumed. We won't have any of it left over. So calcium is the limiting reactant. If all 75 grams of the calcium is completely reacted, you would need only 17.48 grams of the nitrogen gas. We have 25 grams. Therefore, nitrogen is in excess. That's pretty important. It's not as important as knowing that the calcium is a limiting reactant, but it is important to know that one of these is going to be left over. We're going to have some that remain unreacted. Alright, part B. Now we can calculate how much of the product is produced. Now that you know who your limiting reactant is, now we start with our amount of reactant, our limiting reactant. So we've got 75 grams of the calcium because, again, in the previous calculation, we determined that the calcium is our limiting reactant. It will run to completion where we'll have extra nitrogen. Once all that calcium gets consumed, we're no longer making any more calcium nitride. So again, convert the grams to moles, then use your mole ratio, and again, be aware from the balanced equation, your mole ratio, we're going to get rid of moles of calcium down here. So the moles of calcium will go on the bottom because we started with calcium. We're going to moles of calcium nitride here. And then, since the question wants to know what is the mass, if it's asking for the mass, we're looking for the number of grams. We're not looking for moles. We're not looking for anything else. We're looking for grams. unless it says milligrams or kilograms or anything else. Mass is grams. So the molar mass is given here, and then we'll determine from the calculation that if all 75 grams of the calcium reacts, we'll make 92.5 grams of the calcium nitride. All right. The last part, sometimes this question's asked. It says, finally, calculate the mass of the unreacted reactant. Unreacted reactant. It's fun to say that. Now, what does unreacted reactant mean? Well, if we go back to our balanced equation, where we determine that the calcium is our limiting reactant and our nitrogen is in excess, not all of the nitrogen is going to react. We're going to have some leftover nitrogen. The question that's being asked is, how much is left? Well, if we look back at our limiting reactant step, we got lucky. We chose the limiting reactant. We're not always this lucky. If we would have started with nitrogen, it would have been okay. Still would have been able to determine the limiting reactant. But had we started with the nitrogen, we would need to do this calculation right here down in part C. But since we were good, sometimes it's better to be good than lucky. Sometimes we get good, sorry. But in this case here, we've got 17.48 grams of the nitrogen. We know that that's the excess. So when we come back down to our problem here, we've got 17.48 grams of the nitrogen is consumed or used, however you want to say that. 17.48 grams of the nitrogen has been changed into the calcium nitride up here. Alright, so the question is, how much of the unreacted reactant remains? How much did we start with? Well, we started with 25 grams. We used 17.48. How are you going to determine how much is left over? Hopefully you're saying take the difference. And what you'll do is you'll take the difference. You'll take the 25 grams minus how much is used or consumed, and this will tell you how much of the unreacted reactant remains. Now, I've got a note on here. Hopefully I can get it up there for you. I've got a note on here that states that the last part, this part was easy for us because we accidentally picked the limiting reactant back up here in part A. Had we not picked the limiting reactant, in other words, started with the nitrogen, again, we would have had to do this calculation, this very calculation in part C to get how much of the excess was actually used so we could determine how much was left over. If you have any questions, again, please do not hesitate to ask.